This lecture will cover percent yield. Some things you want to make sure that you have before you get started. Make sure you have a periodic table, your objective sheet, and a calculator. So percent yield. We use the percent yield to determine what percentage of a product we actually got in lab out of what we expected to get from our stoichiometry relationship. So up until this point, especially when you were doing limiting, you saw or you could predict how much of certain products you would get. Now, when we go into lab, we don't always get exactly what we expect to get mathematically. There's errors that occur. Maybe you didn't measure exactly the mass. Maybe you didn't extract all of something. So many things could happen. So we're not always going to get exactly what we thought. So this percent yield is how much did you actually get of this product compared to what your stoichiometry said you should have got. So let's start out with a non-chemistry example. So I'm sure most of you have made cookies before, or you watched someone at home make cookies. So let's say you do this recipe and it says that you're going to make 24 cookies from the batch that you're making. You go through and you mix all your eggs and your flour and your milk, and then you go and drop your cookies on the tray, and then you count and you only have 20. So you were expected to make 24, but you ended up making only 20. Now, what we call this, we can call this our theoretical yield is what you should make. So we should have made 24 cookies. Then we have another term that we're going to be using, and that's called the actual or the experimental yield. And this is what you actually made. So our actual or experimental was 20 cookies. Now, to find out what our yield is or what our percentage is, it's just a simple division. So you take your experimental or your actual and you divide it by the theoretical. So you're going to take your 20 cookies and you're going to divide that by your 24 cookies, which gives you about 83%. 20 divided by 24 equals 83%. So what that says is you made 83% of what you expected to make. So these terms right here, theoretical yield and actual or experimental yield, you're going to be using those a lot. And it's very important that you are able to keep track of them and identify which value is your experimental and which one is your actual, so you're doing your math correctly. Okay? All right, so a chemistry problem. We have 33 grams of hydrogen that reacts with 300 grams of oxygen to form 250 grams of water. What is the percent yield? Now, first thing that you have to do is write a balanced equation. We know that we have to have a balanced equation so we can use all of our stoichiometry relationships, so that's step one. Step two, it's not going away. Got to find that limiting reactant, because your limiting reactant is going to be what determines how much of a product you are going to make. So we have to determine that first, and then we're going to determine the amount of product from the limiting reactant. So it's important that you are familiar with and able to do limiting reactant problems before we even move on to this percent yield. Okay, so to find our limiting reactant, here's our balanced equation. So we had hydrogen gas plus oxygen gas. So we'll start out with the 33 grams of hydrogen. And now I'm going to show you a different way that we can do this, okay? First, we'll do it the way that you've done before with limiting, and then I'll show you the variation that'll kind of get you one step it kind of eliminates a whole step. So we're going to go from grams of hydrogen to grams of oxygen and see if we have more than what we need or if we need more than what we have. So got to make this into moles. So 2.02 grams of H2 is 1 mole. Then do your molar relationship. Our mole relationship between oxygen and hydrogen is 2 to 1. And then moles of oxygen to grams of oxygen. Now if we do this math, we get 261.39 grams of O2, and that's what we need. So that's needed. So our need is less than what we have, which means that our O2 is in excess, which means that our limiting is the H2. Now, from here, we need to go from grams of hydrogen to grams of water because we're using our limiting reactant to determine how much product we are going to make. I'm going to show you how doing this step first could give you one less calculation to do. So we're going to go with our 33 grams of hydrogen. We're going from grams of hydrogen to grams of water. So that's your 2.2 or 0.2. That's your molar mass again. Then our relationship is 2 to 2 on this. And then 1 mole of water is 18.02. Units cancel, grams of H2, moles, 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 moles. We're left with grams. And that gives us 297 grams of H2O formed. So that's the number we want, but I'm going to show you what you could have done in the first place and figured out what your limiting was from this as well. This is just another way you can figure out the limiting, especially if you are doing percent yield and you're trying to find the product. It eliminates or could potentially eliminate an entire set of math that you have to do. So now we're going to see how many grams of water we can make from 300 grams of oxygen, or all the oxygen that we have. So 32 grams of O2 is 1 mole. Now we're going oxygen to water, so we have a 1 to 2 relationship. All right, units, grams of O2, moles of O2, moles, moles of water, left with grams of water. And if we do the math on this, it gives us 338 grams of H2O formed. Now, if you remember back to doing limiting reactants, the limiting reactant is going to be the one that limits or dictates how much of a product you're going to form. So with all of my hydrogen, I'm forming 297 grams. With all of my oxygen, I'm making 338 grams. So just by looking at this, which one limited how much product I could make? Which one made the least amount of product? The hydrogen gas. So if you do these two equations, it already gets you to know how much product you have, which is what we want in the end, because now we know how much product we should have made, and then from the problem we know how much product we actually made. So now we know that we have 297 grams of water that got formed. So now's the actual math that we need to do here. So the 297 grams of water, that is our theoretical yield. That is what we should have got. That was from our stoichiometric relationship. So the actual, which comes from the problem, it tells you that we made 250 grams. That's your actual. Or experimental. So what you got in your experiment. So you can use those terms interchangeably here. So now it's just a simple division. You're going to take your 250 or your experimental and actual, and you divide it by the theoretical. When you divide that out and when you multiply out by 100, you get 84%. So we got 84% of the water that we were expected to get. Now, you're probably wondering, what about units? Well, your units of grams per water and grams per water cancel. So this is a unitless answer. Just make sure that you're including that it is a percentage. So first things first, make sure that we are comfortable doing our limiting reactants and then determining our product based on our limiting. That's the key. You need to determine how much limiting you have, or how much product you have, based on your limiting. All right, so go ahead, do some practice problems. Let me know if you have any problems, and good luck.